AI really does feel like magic, doesn't it? But behind every single answer, every image it generates, there is a massive, very real physical machine. So today, we're going to pull back the curtain on the $7 trillion machine that makes all of that magic happen.
I mean, just think about the last time you used an AI. You typed in a prompt, you hit enter, and boom, almost instantly you get a poem or a crazy looking image or the answer to some really complex question. It feels completely effortless.
The response is just so fast, so seamless. It might as well be magic, right? But that incredible feeling of instant knowledge, well, that's the result of decades of research and, as we're about to see, trillions of dollars in actual physical hardware.
Because behind that slick interface, it is not magic at all. It's a vast, power hungry, and unbelievably complex physical system. And it all really starts in one specific place.
This is a data center. The easiest way to think about it is as a factory for the digital age. It's the physical building that holds all the servers, all the storage, all the networking gear that makes AI actually work. And right now, these factories are at the very center of an incredible revolution. And that revolution, it's being fueled by one thing more than anything else: AI's absolutely insatiable demand for computing power. The scale of this whole thing is just staggering. A recent McKinsey analysis projects that by 2030, the world is going to need to invest nearly $7 trillion in data centers just to keep up with the demand.
Now, what's really fascinating here is what is driving that demand. A whopping 70% of it is expected to come specifically from AI workloads. We're talking about all the intense computing needed to train new models and run all of our prompts. This isn't just part of the story. AI is the story.
And this isn't some slow and steady growth. It is happening at an absolutely explosive rate. We're talking about an average annual growth of 33% for AI-ready capacity every single year through 2030. So who's building all this stuff? Well, for the most part, it's a handful of giants. The hyperscalers, think Amazon Web Services, Google Cloud, and Microsoft Azure. They're the ones fueling the vast majority of this demand. They need just massive amounts of capacity to host their own AI models, and of course those built by others, like OpenAI's ChatGPT. This incredible demand means we can't just build more of the same old data centers. We need a completely new blueprint, one designed specifically for the unique challenges that AI brings to the table. And this slide really shows the difference perfectly. Just 10 years ago, a 30-megawatt data center was considered huge. Today, 200-megawatt campuses are becoming the new normal. So why the massive change? Well, AI servers consume so much energy and get so incredibly hot that traditional air cooling just can't keep up, which is forcing this big shift to liquid cooling systems. So you can really break this revolution down into three key pillars. First is location and power. Builders are literally chasing cheap, available electricity. Second is cooling, making that critical shift from air to liquid. And third is the internal electrical design itself, which has to be completely re-engineered to handle all that extra power. But here's one of the biggest bottlenecks in this whole thing. You can build a brand new, state-of-the-art data center in about 2 years. Okay. But building the power grid infrastructure, the transmission lines you need to actually get the electricity to that center, that can take anywhere from 3 to 10 years, sometimes even longer. This timing gap is a massive, massive challenge. But you know how it goes. Where there are challenges, there are also enormous opportunities. This entire build-out is creating a modern-day gold rush for the industries that can step up and solve these problems. So who stands to gain? Well, energy companies, for one, have a huge role to play here. They can develop new markets where power is cheap, they can build dedicated power plants just for data centers, invest in renewables to meet those big climate goals, and, crucially, help fund the expansion of the power grid itself. This opportunity extends way beyond energy into real estate, too. As McKinsey senior partner Pankaj Sachdeva points out, data centers have historically given much higher returns than other real estate assets. And because of the supply constraints we've been talking about, that trend is expected to continue, making them a really attractive investment. And hey, let's not forget the telecom operators. They are in such a prime position. They can lay all the crucial high-speed fiber to connect these new centers. They can offer up their own computing power as a service. And some might even decide to jump in and build and run their own specialized AI data centers. So, as we look at this incredible transformation, it becomes pretty clear that one fundamental challenge rises above all the others. The $7 trillion investment is mind boggling. The technology is changing by the day. But you know what? None of it matters if we can't solve the core problem. The ultimate bottleneck for the entire AI revolution is, and will continue to be, power. Which leaves us with the most important question of all. As we build this incredible new digital world, can we also build the clean energy infrastructure needed to power it sustainably? That, right there, is the true $7 trillion question.